I think um, in the introductory or inauguration of the workshop, I briefly mentioned about the changes that are happening uh, in the recent past about looking at the um, research challenges. I have shared my screen. Hope it is visible.
Still not come.
Okay. Let me check once. Yeah,
Yes,
I think I have to share here.
interesting, you can
Mm,
say.
yeah, let me. Oh, it is telling I'm not allowed to share because I was logged in as director at IIIT DWD for sharing purpose. Um, Director at IIIT. You can unmute, Dr. Das. You can unmute your mic.
I
See
have
that
already
professor.
made you the
Now it is allowed. Let me
yes,
share that.
yes,
Um, um, Hope now it should come up.
yes, sir. While waiting.
Um, is my screen visible?
Not yet, sir. For me, it
Oh,
is
not
not.
yet. Okay.
You are able to share, sir?
I am able to share now.
Oh, okay, fine.
Maybe because of the
Yeah,
network.
low bandwidth will come later. I think so.
Hmm, okay. Uh, there is some issue in the network. Let
Yes,
me. Hmm, just give me a minute,
yes,
please.
sir. Yes, sir. Definitely.
Um, just getting reloaded. Sorry.
Yes, sir.
Um, so, Dr. Das, what I will do is
Sir.
I'm sharing the PDF version of the slide for your. You can pass it on to somebody if
Sir, I can
somebody
handle
can.
no problem. Sir, I can
Yeah,
operate from here.
yeah. Kindly.
Yes, sir.
I have shared it now
In WhatsApp, sir?
in WhatsApp.
Okay, sir. Yes, sir, got it.
Yeah, you can project that and. Did it come?
Yes, sir.
Yeah, you can project kindly.
Let me share the screen.
Mm.
Yeah, good afternoon.
Good afternoon. Just wait. My screen is visible.
Yes, sir.
Yes.
Yeah.
Sir, we can start. Sir.
Yeah,
Sir.
thank you. Thank you, Dr. Sorry for the inconvenience.
No.
Yeah. So, good afternoon, all. Now, yesterday in the inauguration of the workshop, I briefly mentioned few points, and this talk. Able to hear me?
Yes, sir. Yes, sir.
Yeah. So, this talk will be an expanded version of the brief points I mentioned. See, now with the latest developments in the field of artificial intelligence, one of the things all of you may be exposed or maybe already using it, the field of generative AI, and also as a result of that, whatever we call large language models and agentic AI models, and they have a good amount of generalizations that they have achieved compared to the traditional or classical machine learning methods that we were using for development of speech technology. So as a result of this, now researchers are talking about a unified framework for speech and natural language processing. Okay. Um, yeah, by that I mean, see earlier, if I take speech processing community, we take speech as an input signal and process it to develop technologies. And even though speech is backed by what we call spoken language, we were not even paying much attention to the written form of the language. Whereas there are other research community, larger community working in the field of natural language processing, which in short we call it as NLP. They focus on whatever the information, text part of the language, written from the language into knowledge or information. They will convert. That is what they develop the method. So now the time has come where both, if I take speech modality or a written form of the message, both are intended for conveying some information or conveying some meaning during our communication. It can be human-human communication, basically is meant for human-human communication. After computing came, it is human-computer interaction also. But for last several decades, people worked on separately these two verticals. Speech community worked on developing abilities for human-computer interaction using speech modality. Similarly, written form of the language, that is natural language processing community, worked on developing modalities for converting or communicating human interaction via written form of the language. Ultimately, the purpose of both the things is how to convert that into meaning or semantics. Now, with the abilities of generative AI aided by large language models, agentic AI, and so on, now people are talking of the input can be either in the form of speech signal or in the form of a written form of the language, or it can be both, and both are given as input to a system which is called speech and natural language processing module. In short, we call it as SNLP module, where it takes either speech or written form of the message or both as input. Inside that SNLP module, it processes, and the output it gives is the meaning conveyed by that particular input given. Meaning, we are not interested in what are the sound units present there. We are not interested in what are the word sequence they have. We are not interested in whether the phrase is produced is grammatically correct or not. All those things we are not interested. We want to just know whether I'm able to get what is the message that is being intended to be conveyed by that speech modality or written form of the modality or both. Okay. So that is the sophistication at which next generation speech and natural language processing technologies people are developing. Okay. That is where when I consider this unified framework, I'm talking about SNLP is equal to speech plus language part. Language means written form of the language and semantics. That is the focus I have. Okay, so that is where the SNLP unified framework will integrate the speech and speech processing modules, natural language processing modules, and also meaning extraction modules into one module, and that is called as SNLP module. Suppose why this unification required? If you look at the traditional approach, what we were doing, when I give my information via speech modality, one of the important module, speech technology module we use is what is called automatic speech recognition system. And the automatic speech recognition system module is, the purpose is convert the incoming speech signal into verbatim text. It is not interested in analyzing what is the information being conveyed. It's only verbatim, convert the incoming speech into verbatim text. And it doesn't put any intelligence on top of it to understand what is being conveyed by this text. If you want to know what is the meaning conveyed by that text, you have to apply it to a natural language processing module, which will take this verbatim text and extracts the meaning out of it. So essentially, if you consider without unification, if you consider a pipeline module, incoming speech goes through an automatic speech recognition system, which gives me text, verbatim text as output. That verbatim text is given as input to the natural language processing module, which gives me the meaning or semantic. It is fine because we have ASR model technology already developed, NLP technology already developed. We can put them as cascade and get it. It is fine as long as the error is minimum. On the other hand, suppose if I take ASR individually as an ASR system, the error rate is less than 5%. It is okay to use for me in practice. Similarly, NLP module also, there is some metric which is equivalent to error is less than 5%. Individually, those modules are fine. Alternatively, if I put them in cascade, that 5% into 5% will become 25%. So in the cascade, that is where the trouble comes. Error propagation across modules happen. Okay. So that is where traditional pipeline approach is error increases, even though individual modules have low errors, but cumulatively they become large amount of error. So that is where can I have a single module which takes speech bar text as input, and one module directly gives me as the meaning output. Meaning of the output is from speech as input, NLP module output as the output. That's what intermediate converting into verbatim text is not there. And that is called as the unified approach. Now, that is one part. The second part is, if I take written form of the language, of course, you give verbatim text as input, it generates the information to be, it meaning of the verbatim text. But in the written form of the language, as all of us know, it has lost a lot of richness of information that is there in the speech format. For example, emotional aspects are exhibited better in speech modality. The prosody part means how the pitch is changing as a function of time. They all add richness to the speech signal and the speaker information. All those things are not available when you go for text part. So that is where even the verbatim text to meaning extraction by an NLP module can be enhanced. The performance can be enhanced if I also integrate speech modality into that NLP module, where all this richness information can be extracted and given additionally to verbatim text, along with verbatim text, to have improved decoding that is coming out of the SNLP module. Okay, so that is where the usefulness of the unified thing comes into picture. So that's where the core principle, previous slide, please. The core principle is language is modality independent. Okay, whether it is a spoken form or a written form, the language is a backbone for information conveying. Only thing is that language can be realized either in the spoken form, which results acoustic realization, it results in speech, in symbolic representation, it results in text. The unified representation doesn't bother about the spoken form of the language or written form of the language. It focuses on extracting the meaning conveyed by one or more of these modalities. Thank you. Next slide. So when I say unified SNLP architecture, I have multimodal input. At least in this case, I'm talking about speech and text as input. And they, what we do is, even though speech, we have some no sound units are there. From the sound units, we transform them into some no unique representations. Equivalent of a sound unit representation, but I'm telling some representations we can transfer. Text is already having some representations, which is the alphabet set we have. That itself is a visual representation of the basic elements of the written form of the language. Similarly, speech also you can have a basic representations. But the interesting in the unified framework is you can code both the representations from speech and the representation from text to the same shared semantic space as the representations, to some common space where I have some units representing speech form of information, some units representing the text form of information. The shared semantic space is there. That can be done with the help of transformer architectures we have. And then once I have the shared, for example, essentially what I'm trying to say is I'm going to get the unit representation. For example, in the written form of the language, I have orthographic representations. All of us can appreciate that. For example, all these English alphabets are the orthographic representation for consumption by the human visual perception. Similarly, if I take the spoken form of the language, I have sequence of sound units. That is for the auditory perception. Now, when I say shared semantic space, I have an unit in the shared semantic space, which is a joint representation of both audio realization.
Sir, you are not audible, sir. Sir, you are not audible.
Once I have the joint representation of all the audio information together with unit, and this you can use for any later downstream task I want to do. One of the downstream tasks is meaning extraction, semantic extraction. I use both. Not audible. I'm not audible. Last. Hello. Hello. Hello.
Sir. Yes, sir.
Am I not audible?
You are audible, your voice is cracking a little.
Hello.
Yes, sir. You are audible, sir.
But somebody told you're not audible. That's right.
Voice is cracking, yeah. Sir.
Yeah. So I'm sorry, you have to bear with that because I'm in a remote place. What I was telling was, if there is any challenge, please alert me. Then accordingly, I'll adjust again. So what I wanted to say is, when we are talking about unified representation, we are taking inputs from the speech modality, taking input from the text modality, and convert them into a joint representation of acoustic and text information. And those are the basic units. And these basic units are the entities which we use for downstream task. The downstream task, simplest one, the basic assumption we kept was in terms of meaning extraction. From these joint units, how do we devise or develop a meaning extraction unit? Okay. Like this, we can have many other downstream tasks that we can do. And once I have that, and the output of that task can be obtained from a what is called a generative decoder. Generative decoder we can do. Next slide. Next slide. So the input layer for a unified SNLP system, that is speech and natural language processing, will be a raw speech waveform can go as input. Raw speech waveform or the spectrogram, and the text tokens, text phrases can go as input. And it can accept the input in both the modalities, one or more of these modalities. So, and it processes both these modalities simultaneously and put them into as basic representations in the semantic space, joint semantic space or shared semantic space. Next slide. Next slide, Professor Satya. So now, once I process that, I will have a no, previous slide. Previous slide. Hello, previous slide, Professor Satya. No, next slide, next slide. Next slide. Next slide. Next slide.
Yes, sir.
Not
This one,
able
sir.
to.
This one?
This one. No, no, not that. See, after that raw speech, the next slide I wanted to go.
This one, sir.
Previous. Joint embedding of speech and text. That is the one. Joint embedding of speech and text. Previous. This is after this. Oh my gosh.
This one, sir.
No. Previous one. Joint representation. After this. Okay. No. After this. Next. Yes. This is joint embedding. See, we want to convert the incoming speech and audio information into joint embedding for speech and text. I get representations which captures the information conveyed by both speech and text simultaneously if it is there. Then accordingly that joint representation will encode the meaning part of it and also the context part of it, in which context it is coming. And also it will preserve the speaker and prosodic information. Okay. So that is the representation of this joint thing. This is the very core or kernel of a speech and natural language processing module, where I have a joint representation of that. Next slide. Yeah. Here, for example, what are the modules present in the SNLP? Task modules. There can be speech recognition module. There can be natural tasks. What we can do? You can do speech recognition. You can do natural language processing. You can do translation. Translation means message from one language to the other language. You can have a dialogue system where I can develop dialogue way of engaging with the user. A dialogue system means you listen to that question and answer session like this and engaging the user. And you can have a speaker and language recognition system. You can also have semantic and emotion recognition system. So accordingly, a single SNLP module system will be able to support multiple tasks as long as I have captured the essence of information that is being conveyed by the input speech modality or text modality or both in the form of basic entities or representations. Once I have that, I can use it for multiple tasks like this. These are all downstream tasks, what I am telling. Next slide. So now the generative decoder is, once I do any of these downstream tasks, how to convey or generate the output of that module. And that is called the generative decoder. It can generate either the text part or the speech output. Suppose if I am doing speech recognition as a downstream task, then it will generate text. On the other hand, if I am doing text to speech synthesis, it will generate speech as the output. On the other hand, if I am doing a dialogue delivery system, it will enable a conversational AI system. So in that way, and you can have multimodal aspects, supports multimodal generation. It can generate simultaneously text part and speech part as well as the dialogue system also it can do that. Mm. So in that way, the generative decoder, which is the output module of the SNLP system, it will have that multiple capabilities. And it is very critical in the current generation when we are talking about generative AI systems. Next slide. Next slide. Hello.
Yes, sir.
Next slide. Next slide.
Next. This one, sir?
Next slide. Yeah. Um, just, just 1 minute, Satya. Just 1 minute.
Yes, yes.
Dr. Das.
Sir, yes, sir.
Yeah. Sorry, there was some urgent call to
No
attend.
problem, sir. You can continue.
So, what I was trying to say is, um, people are now talking about, not talking speech processing and natural language processing in isolation. You build a unified module, which is a unification of both speech processing and natural language processing, where it can accept input either as speech or as written text or both, and from that input you extract a joint representation information. Okay, and that representation information, uh, you can use it for any of the tasks. Either you can do any of the speech processing tasks or any of the natural language processing tasks, or a combination of them. That is what it is telling. Okay, that is where you have universal multimodal encoder, shared semantic space, task adaptive layers, and generative decoder. Then this is what is the futuristic system people are talking about. Okay, next slide. Okay, so when I'm telling about unification, initially when the information is being generated in the speech modality, the information is stored in the speech signal. So how it is represented in terms of sequence of sound units, and also the higher level information like prosody, emotion, speaker information, all those things are information, represent. Similarly for text, we have at the basic level the orthographic representation and their valid combination to become words, and that is how the information is present. Now I will take both these modalities and convert them into some embeddings. Okay, that is where the unification happens at the representation level itself. Once I take speech representation in the form of raw waveform or spectrogram as input to the deep learning model, generative model, and the text representation also as input to the generative model. And when we are processing through the several layers of the deep learning model, I get joint representation. That is what I call it as joint representations. Same embedding for multiple modalities, and same model for multiple tasks. Then the speech and natural language processing module will integrate both speech and language processing, and it will enable, we are putting in a shared semantic space, and accordingly it will support end-to-end AI systems. Okay, speech and unified language intelligence layer we will have. Okay, so now, even though I'm using some jargons, new jargons here, please pause for a while and understand. So all of us, for example, if I take English, we know how to write a message in English. We also can understand message, decode message from the spoken speech signal generated for the English language, from the English language. Okay. Now, as a human, when I am able to, um, want to extract the meaning conveyed by one or more or both the modalities, as humans, I do. Okay. And that is what the capability we want to develop now on the computing machine. Next layer, next slide. Next, okay. So now let us see how do we do the spoken language processing part. How do we do the spoken language processing part? So from speech signal, how do I, incoming speech signal, how do I have a meaningful interaction with the computers? That is the spoken language processing I'm talking. If you recall in the inaugural session, I also mentioned, when there are languages we do not have script. If I do not have script, but still we are able to convey the meaningful information to other person whom we are interacting. And that is essentially spoken language processing. Without even, we may not involve the text part. But suppose if that language has some textual representation, we can further enhance the output. or the resulting downstorms.
Yes, sir.
Hello.
Yes, sir.
Sorry. Take this. Next slide. Yeah. So, the spoken language processing, as I told, it will enable the computing machines to understand and respond to speech. So now, suppose in the spoken language, in any particular language, I also have no written form of the language. When I take this SNLP framework, I can integrate speech processing, natural language processing, and dialogue systems together um, to have a meaningful interaction with the computer. That is what when I take speech spoken language processing, it will essentially involves a speech processing, which is essentially converting the incoming speech signal into verbatim text, understanding, which is nothing but converting the verbatim text into meaning, the meaning conveyed by that verbatim text, and interaction. Interaction is the dialogue part. How do I once I understand what is being said, how do I respond back to the user such that no, we can have a communication, fruitful communication with the user, and that is the dialogue part of the things. So in that way, a spoken language system will have three aspects. One is speech processing aspect for converting speech into verbatim text, understanding part converting verbatim text into meaning, that is natural language processing, and dialogue systems part, which is converting the meaningful text into, based on that understanding, I will respond to that. That is the dialogue system. Next slide. Next slide. Sorry. Next slide. Yeah. Sorry. Part of.
So this one, sir.
Yeah. I think. Suppose if I want to do this spoken language processing in a traditional time where we are doing classical machine learning, we had so many modules in the pipeline. For example, there is an incoming speech signal, you have an automatic speech recognition system, you apply speech as input to the automatic speech recognition system, it converts into text, and that verbatim text you apply to natural language understanding system, which is nothing but NLP module. And it will understand and says the meaning of the verbatim text. And from there, giving it a dialogue manager system. And the dialogue manager will know, once you understand, the dialogue manager will decide what is the way we have to respond to that query or the question. And accordingly, the query will be generated, response will be generated. That is natural language generation. And that response can be either in the form of text or in the form of speech. If it is in the form of speech, I will use text-to-speech synthesis system. If you see now, in the traditional pipeline fashion, I have one ASR technology, one natural language processing technology, another dialogue manager technology, and another is text-to-speech synthesis technology. At least 4 modules are there. Individually, they may be good, but when you put them in pipeline, the error will be cumulative. That is where the challenge comes with the pipeline architecture. Next slide. So, for example, I think this I will not spend much time. Other speakers will tell what is about automatic speech recognition system. Next slide. and what is natural language understanding. The purpose of this natural understanding system is detecting the intent behind the message that is coming inside, or entity extraction, what is the entity under which they are talking about, and semantic interpretation, what is the meaning that is being made, and so accordingly, with the help of semantic meaning, entity, and intent, it will transform the input verbatim text into a structured, meaningful entity. Next slide. That is the natural language understanding. Then dialogue management is, it will maintain the conversation state, handles multi-turn interactions, takes system actions. Next slide. In the natural language generation, it will generate human-like responses, and it ensures coherence and fluency, produces system responses. Next slide. In the text-to-speech synthesis system, it will convert text into speech, and it adds naturalness and prosody, and accordingly, it will enable the voice-based interaction. Next slide. So, in the modern spoken language processing systems, when I'm talking about SNLP, you can see, speech is going to a unified module, which is a SNLP module, which is a combination of automatic speech recognition system, natural language understanding system, dialogue management system. And what you get is output, you get the semantic representation, what is the meaning to be conveyed. And accordingly, once that meaning comes, it gets generated as a response, and that response will be given out as speech or text. Now you can see the end-to-end system. SNLP is an end-to-end system. There are no individual modules. Accordingly, there are no cascading errors occurring here. And that is where the people are talking about developing next generation unified systems. Next slide. So the key shift, accordingly, what is happening is, from the classical modular pipeline system, we are going to end-to-end systems, and from text-based system to speech to semantics, we are talking about speech to directly converting into meanings, and it is driven by the latest developments in the deep learning and general. Next slide. Suppose if I take what are the core tasks in spoken language processing system, that unified module should combine the activities of speech recognition system and the activity of spoken language understanding and the activity of dialogue systems. All these three put together as one module, and that will give the fundamental capability of a spoken language processing system. Next slide. Next slide. Hello.
Yes, sir. This one?
Next slide. After core tasks, next slide.
Okay, sir.
Where I think, dialogue system. So in the dialogue system, okay, next slide. Challenges will be, of course, nowadays we are talking about collecting data from having a lot of acoustic variability, and there can be ambiguity in the language being conveyed because of the disfluency. And we will be speaking in multiple languages. The code switching may happen, and real-time processing may happen. Key research challenges will be real-time processing that may happen. These are the key research challenges that is required in the current generation. Next slide. So, of course, nowadays people are asking about, suppose traditional metrics, suppose if I use automatic space size word error rate. So Now we are talking about intent accuracy, whether the intent is detected properly or not. Intent means, no, it is a gross level meaning. For example, no, um, I'm not able to switch on my video. Um, Due to low bandwidth, I'm not able to switch on my video. Since I'm connecting from a very remote place, I will not be able to switch on video. So like this, I can use multiple sentences. Okay. But the intent behind that is the common intent is I will not be able to switch on the video. That's all the common intent. Now, whether immaterial of what verbatim text you are using in what different manner, whether you are able to convey the intent accurately or not, that is that intent accuracy. And we are talking about whether the intent is able to detect properly. I don't care whether the verbatim text is decoded properly or not. And task success rate, we are talking about, I'm talking about, no, as a SNLP system, I want to build a what we call a dialogue management system. As long as the dialogue management is going out fine, 99% of the time it is properly doing, that is the task success rate. I don't care whether individually the errors are there or not. Similarly, user satisfaction. As a user using different tasks, the performance of this one, otherwise I have no, then that is the only measure I will take rather than word error rate or some objective measure that we are trying to do. Okay. And accordingly, now people are talking about combining the technical metrics. Of course, word error rate and other things we can use to some extent. But more than that, we'll also use the user metrics. User metrics like intent accuracy, task success rate, user satisfaction. All
You are not audible, sir. Yes, sir.
oh,
Yes, sir. Now audible.
next slide. The applications, if you see, people are talking about developing voice assistants, customer service automation. Previous slide. Healthcare systems, educational tools, like these wide real world applications, they will be talking about. Mainly because they want to have a very, I will say, very smooth interaction with the computing machines. Between humans and machines, they want to increase the smoothness with which communicate with computing machines. Like human communication, we expect the communication also should happen in a very smooth fashion on the computing machine. So that is the level where people are looking forward. Next slide. Next slide. Prasad Das.
Yes, sir. This one?
Yeah. So, for example, if I take in the example task, yeah, this is correct.
Sir.
So, when I'm talking about an example thing now in the current generation, I take speech, apply as input to the large language model, and the large language model will give me the reasoning or the meaning that is being conveyed, and that gets converted into response either in the speech or text format. Okay. And so accordingly, I have end-to-end conversational intelligence system that I have built. Next slide. So, if you see how I can realize this modern spoken language system, spoken language processing system in in the unified SNLP framework. So I can have unified speech and language processing module. We'll have shared semantic representations, speech to semantic models. So these core modules are there, sub-modules within the SNLP module. We can use it for spoken language processing, because the very purpose of spoken language processing is speech processing, understanding, and dialogue management. So if I have these things, unified speech and language processing, shared semantic representation, and speech to semantic models, then we can have, SLP systems can be built using that SNLP system. Next slide. So accordingly, in future, now the performance of speech-based systems are so good. People are talking about fully voice-based interfaces, and they are not, want to have emotion-aware systems. It's like no human-human interaction. Human-human interaction is fully voice-based interaction. We are sensitive to emotions during conversations. We can do real-time translations. We can have autonomous conversational agents. So like this, we are trying to get the tasks that are being done by humans in human-human interaction. We want to automate and bring them onto the human-computer interaction space, so that we can have a very intelligent communication system, which is sensitive to rich information sources that are there in the speech signal. Next slide. So to summarize, if I take spoken language processing, it will essentially integrate both speech and language, speech processing as well as language understanding. It will enable natural human-machine interaction, and we are moving towards a unified and generative models case. So accordingly, we'll be able to realize a spoken language processing system which has a combination of speech processing, natural language understanding, and interaction. Next slide. Now, if you take a specific case of spoken language processing, specific case, a good example is a conversational AI systems. Okay. In the conversational, as the name itself indicates, an AI system which has the capability to converse with humans, and that we call it as a conversational AI. The best way to enable this conversational aspects of AI system is through speech modality or text modality or both. Okay. And this is where the unified framework plays a very important role. That is where now from pipeline, we will go for a generative intelligence system, so which can help us to realize such conversational AI systems. So just to give an example now as a use case for conversational AI system, so we are talking about, suppose I am driving on a highway in my car. My hands are on the steering, and so accordingly, I want to call some person and get my activity done, and that is a conversational AI system which has different speech modalities, text modalities, all those. It's like, as if, I am calling my personal secretary and asking some details, human personal secretary. The human personal secretary will read out the details. Based on that, I give some instructions. Based on that instruction, the secretary will do that activity and report back to me, and the task gets completed. And that is what is that conversational AI system. And that is what we are talking about as a conversational AI agents that people are looking into. And that can be realized by as a part of this SNLP module. Next slide. So, as I mentioned, this conversational AI will enable natural interaction with machines. and it will supports both the text and speech interfaces and combines the natural language processing, speech processing, and artificial intelligence. The goal is we need to have human-like communication with machines, like a virtual assistant, as I told, Google Assistant, Alexa, or customer service chatbots, and AI co-pilots for coding, writing, education, and widely used industries. Okay, that's what. Okay, next. So, uh, if you see, uh, there are some signature or some primitive versions of conversational AI systems can be appreciated. It was there for rule-based systems were there earlier. Even statistical natural language processing systems were there. Deep learning systems were there. Now we are talking about generative AI-based systems. So where if you compare to rule-based system, generative AI system for more conversational AI will be a very advanced system, which will be an intelligent and context-aware system. That context-aware is very important. Intelligent means it will smoothly handle the dialogues. It is sensitive to the emotions, sensitive to the speaker, sensitive to the language, like that. That is the intelligent behavior. And this context aware will be there. Next slide. I think this is this repetitive slide, like in the this is also a spoken language processing. Conversational AI system is nothing but a spoken language processing. So this is a pipeline module they have like this, but what we are thinking is an unified module. Next one. So of course, this is essentially what is DSR does. Slide. Next slide. Again, this also has come earlier, natural language understanding. Next slide. Dialogue management, this also it has come earlier. Next slide. This also it has come, natural language generation. Next slide. So text to speech synthesis also has come. Next slide. So this modern architecture, no, what we are talking about in a conversational AI system, user input comes. I apply that user input to large language model, which is a generative AI system, and it generates the response, and that response will be played out or engaged in the conversation. And that is what that end-to-end learning replaces modular pipelines. So that is the things people are talking about. Next slide. Okay. So from pipeline based, we are going to end-to-end system, intent to context aware. Okay, next slide. Since conversational AI is an example of SLP case study, some of these slides are getting repeated. Rule-based system, retrieval system, generative AI systems. Now, current generation, the generative AI systems dominate the modern conversational AI domain. Next slide. So, essentially, we are the core modules of conversational AI will involve some approaches that we are developed in natural language processing area, some approach in speech processing area, some recent developments, machine learning and deep learning, and knowledge graphs and database. All these things are integrated to get a conversational AI system. Next slide. Of course, the evaluation metrics typically, for a natural language processing or translation task, we have blue score. Like word error rate for machine translation, we have blue score. Whereas, as again I told, task success rate, user satisfaction, they are also subjective scores. Both can be considered to see how the system works. Next slide. Next slide. Okay, this I have told already. Customer support, healthcare, assistance. Then we can have any of those things we can have. Next slide. Yeah. So now this is a wish list, but what is that? Now why I'm bringing this is the research challenges that we are putting in the current generation is not know how do I build an automatic speech generation system, make how do I bring down the order rate. They are there as a traditional task, but we are looking at a much broader level. Next level difficulties or challenges we are trying to address, like context understanding. This all we are humans, we are very experts in that. So, for example, if some dialogue is going on, then I say, what is the context in which this person is saying this statement will say? That is the contextual understanding. And we have the capability to deal with the ambiguity in the language and how to handle long conversations. Our conversations can go on for half an hour, 1 hour, like that. How do I handle that? Okay. And how do I avoid biases and ensure fairness in our conversational AI? We give multilingual support. So, and these are all some of the open research challenges are still there, and that is where people are talking about. So that is where no, we don't really just focus on individual modules that ASR, NLP, like a classical machine learning era. We have to move up. If I want to develop speech technologies which are of better value in the current segment. Next slide. Okay. Conversational AI in generative AI, so it should have ability to handle long context understanding. Long context understanding means we all do. We go and attend a meeting. Okay. We all start with an agenda item. Somebody reads the agenda item, somebody comments it, and somebody else comments it. Like that, this conversation goes on across the table for maybe half an hour, 1 hour, 2 hours. But still, as humans, we are able to keep that connectivity. And we can relate, even towards the end of the meeting, I can relate the opening remarks from there, how that opening remarks came, and okay, finally, this is how we are concluding, and link the two. And that is that long context understanding. So, whereas in the conventional ASR system or NLP system, we are talking about take a phrase or a sentence, try to get the meaning or something. But you should be able to keep track of the context for a longer duration. And how that is where the purpose of conversational AI comes into picture. The use of personalized responses, then multimodal interaction. So rapid advancement, happening in these capabilities, and that is where the many research challenges are there. Next slide. Of course, this is end-to-end conversation. I think I've already told enough. Next. So what we are talking about now is integration of speech and language. Language means in written form of the language. We are talking about unified slide. So I think this I mentioned the future directions for research in the speech and natural language processing. They include emotion aware AI systems, real-time translation we should be able to do, autonomous conversational agents we require, multimodal AI systems are required. So in that way, the future lies in intelligent interaction systems. Okay, that is where the research is moving. Next slide. Next slide, Professor. That's it.
Yes, sir. 59.
Yeah, thank you, thank you. So these are the that thought process I just wanted to mention. Now I'm I think just to summarize, it's all good to understand the classical task as the researchers we are trying to work. That's all fine, but the field has advanced significantly. From a practical usability point of view, people are now talking about developing conversational AI systems whose performance or expectations are are at much higher level, not in terms of objective measures, but in terms of user satisfaction, task, performance, all these things. So that is where, fortunately, we have good generative AI models and techniques have come. With the help of that, we will be able to develop such conversational AI systems. I suggest all of you, look into the latest literature review in that direction and try to bring out some tasks which are relevant for all of you. Okay, I'll stop it here. Let me know if there are any questions.
Yes, participant, any question from your side? You can unmute yourself and you can ask the questions. Yes, anyone having any questions? You can unmute yourself. A student from Nigeria, you can ask some question if you have. You can unmute yourself. I've already given the permission. Sir, one question in the innovations also I had asked. So if I'm trying to open one speech lab, what are the minimum requirement needed from our side? What are the things, software or that something?
See, that Jagabandhu will be able to tell. See, what we require is some. First thing is, as an education institution, you should get the annual subscription for the NIST data sets, so that now you get access to large. It is a institutional subscription, very low cost they give, some $2,500 per year or something.
Okay.
So that you have access to large amount of data set, and you should have some subscription to GenAI tools. Okay.
Okay, sir.
Because students can explore research modules in that. Then you should have some good, decent version of GPU server.
Yes. That is
And some recording, good microphones for recording speech data.
Yes.
And good speakers.
Okay.
And a decent recording studio. You don't require like a recording booth, I will say.
Okay.
You don't require a recording studio like a television broadcasting, but a decent thing where external noises are attenuated. If those things are there, I think should be fine.
So we are going to, if we are going to collect the data and we are one kid should be one repository, speech repository. So that also required some license or something? No, not required. We are only stored anywhere. And
Which one?
if we are able to collect some data, speech data, and we want open one repository, for that one, any license is required from someone or no? We can store anywhere.
Open. I did not get. What is open?
Speech repository means that database. Speech database. We are going to collect the data from this indigenous people or African students. So where we are going to release that one?
See, when you for storing it, making it public, absolutely there is no problem, no permission required.
Okay.
Okay. Only thing is, from the subjects who give speech data, from them you should take the consent.
Okay, sir. Okay,
consent, and also you should not reveal out the personal information. Mask the personal information and then allow it.
Okay.
Yeah.
Thank you very much, sir. I think you are given your time. You are in remote place and also able to give the time. And thank you very much. We will be in connect with you for that.
Thank you. Thank you all. Thank you.
Thank you, sir. Namaskar.
Namaskar.
Thank you, sir.